All right, so welcome guys to the next video. Hope you guys had a great fall break. Let's jump right in here to our next video. So we're going to be talking about electron configuration today. Okay, electron configuration can get kind of complicated, and I know that we're doing things through virtual school. So I'm going to do my best to make this as simple as possible, as nice and easy as possible. There are some rules that we're going to have to learn today. And so as long as you pay attention to the rules and are willing to practice a little bit, this will not be that bad, even though at first it might sound very complicated. Okay? So just trust me a little bit, give it a good effort, and you're going to be just fine today. Okay? So let's review just a little bit about what we know about atoms so far. We should know, based on what we talked about before fall break, that this right here, the center part of an atom, is called the nucleus, right? And these red and blue particles here are called protons and neutrons, okay? The electrons are these on the outside here, okay? So you probably recognize this sort of symbol from like Jimmy Neutron or something, right? This is kind of what an atom looks like, but what we need to do today is figure out where exactly are the electrons. Are they actually flying around in nice little loops like this? How could we figure out where they are? Because it actually is very, very important where the electrons are. Most of chemistry is determined by electrons, okay? So once again, protons and neutrons are here in the nucleus. They're sitting there together at the center of every atom. The electrons are on the outside, and so what we're going to do today is we're going to figure out where they are, okay? To put that into more academic terms, our objective for today is for you to be able to represent an element's electron configuration in standard notation, okay? So that's what we're going to learn how to do. We're going to learn how to write down the electron configuration, which is like the electron's address, in standard notation, okay, which is just like the basic way, okay? So, where are the electrons? So like I said before, in chemistry, it is really important to know the location of the electrons inside of an atom, and that is what the electron configuration is called. The electron configuration of an atom is the location of the electrons inside that atom. It's like their address, okay? So your address is where you live. The electron configuration is like the electron's address, and it tells us where they are, where they live inside of an atom, okay? Okay, so it can get a bit complicated, like I mentioned at the beginning, but I'm going to be giving you guys some rules today, and as long as we can follow the rules, then it'll be just fine, okay? So the places where electrons can be found are called orbitals, okay? So electrons can be found in what are called orbitals. Orbitals have two properties: their energy level, which is a number, okay, so like number 1, number 2, number 3, and a type. Okay, so the orbitals have two properties: their energy level and their type. The energy level is a number, 1, 2, or 3, or 4, or bigger, and the type is a letter, and there are 4 types, okay, S, P, D, and F. I'm not sure why those are the letters, but that's what they are, okay? So those are the different types of orbitals, okay? Energy levels, so the number out front of the orbital, tells us approximately how much energy the electrons have, okay? The first orbital is like your lowest energy orbital. That's the 1s orbital, okay? The last orbital, or the highest energy orbital, is 7p. Okay, this is not super important. This is basically just going to tell us where we're going to start and where we're going to end. The types, so these are the letters. The types are actually super important. The types tell us how many electrons that orbital can hold. So an s orbital, like this one right here, the 1s orbital, that can hold 2 electrons max. Okay, so that's the maximum number of electrons that can fit in there. A p orbital, like 7p, can hold 6. A d orbital is even bigger, it can hold 10. And an f orbital is even bigger than that, it can hold 14. Okay? This is what electron configuration looks like when you write it down. Okay? So this would be for a fairly big element. There's lots of electrons here. Okay, so that's what that little number is up at the top. That's the number of electrons that are in this orbital. Okay, so the 1s orbital would be written like this, right? This is the energy level for that orbital, and this is the type. Okay, so the 1s orbital is a place where electrons can be. And what this says right here is that there are 2 electrons in the 1s orbital. And then what this says is that there are 2 electrons in the 2s orbital. And there are 6 electrons in the 2p orbital. Okay, so this, once again, this would be an electron configuration for a big element, right, that has lots of electrons. Let's look at a few examples with some smaller elements. Okay, so I'm actually going to zoom this out a little bit to where I can write in here. I am going to need my periodic table while I work on this. Okay, so you might have the hard copy of the periodic table that I gave you. If you don't have that, then remember you can always go onto Canvas and click on the periodic table link to pull up a periodic table just like this one. Okay, so let me zoom in a little bit here. Okay, let's do this first example. This is hydrogen. Okay, so my objective here, right, is to be able to write down the electron configuration for hydrogen. The first thing I have to do is I have to figure out how many electrons there are in hydrogen. And that is an easy thing to do, okay? All you need is the atomic number, okay? So you need the number of the element. That's going to tell you how many electrons there are in that element. So hydrogen is up here in the top left corner. Its atomic number is 1. It's the first element. So atomic number 1, that means I have 1 electron. And so I only need to figure out where that 1 electron is. Okay, and so here's how this works. We are going to use this chart, okay, and you don't have to memorize this. This is a chart that you're always going to have access to. This chart is going to tell us how to do the electron configuration, okay? We're always going to start up here at the start sign, and we're going to travel down these red arrows, okay? And we're going to put electrons in these orbitals until they fill up. And then we're going to go to the next orbital, and then we're going to go to the next orbital. For hydrogen, it's very, very simple. Okay, so we start up here. The first orbital that I get to is the 1s orbital. So I'm going to write that down. And then I'm going to put electrons in there until I run out of electrons or until it fills up. Well, I only have 1 electron, right? So I'm going to put my 1 electron in there. And that's it. I'm done. Okay? That is the electron configuration for hydrogen. Okay? It's just 1s1. Let's look at the next element. This is helium. Helium is atomic number 2. Okay? I would show you my periodic table, but I just want to get these done nice and easy. So helium is atomic number 2. That means it has 2 electrons. So we want to write down the electron configuration. Where are the 2 electrons in helium? Well, we're going to start over. Okay, so each element is like its own new problem. Okay, so I'm going to start up here at the top, and I'm going to go down here. First place I get to is the 1s orbital. That's going to be the first place for every single element. Okay, so every single element is always going to start with 1s. Okay, so first place I get to is the 1s orbital. S orbitals can hold 2 electrons. I have 2 electrons, so that's it. That's all I'm going to write. That is my answer. That is the electron configuration for helium. Hydrogen and helium look pretty similar. Okay, the only difference is that little number, right? And the reason those are different is because those elements have different numbers of electrons. Okay, lithium is number 3. Okay, so we're sort of marching our way up the periodic table here. Lithium is number 3. It has 3 electrons. Okay, so here's where we encounter our first sort of complicated step, right? We're going to start here at the beginning. First place we get to is the 1s orbital. S orbitals can only hold 2 electrons. Okay, I cannot write 1s3 because this orbital is not big enough to hold 3 electrons. It can only hold 2. Okay, so it can only hold 2 electrons. I can only put 2 of them in there. Now, I have 3 electrons to start. So I took 2 of those away, and now I have 2 of them that are in the 1s orbital, but I have 1 that's left over. So where is that one? where does that third electron go? So that is what this chart is for. Okay, so you're going to follow the red lines. All right, so when you get to an orbital and you fill it up like we just did, when you get to the end of an arrow, you need to go to the start of the next arrow. So the next orbital that I get to is the 2s orbital. Okay, and I have 1 electron left over, right? Because I put 2 of them here. So I have 1 electron left over. This is my electron configuration for lithium. 2 electrons in the 1s orbital, and then the third electron in the 2s orbital. Okay, these little numbers here, 2 plus 1, should add up to the atomic number, or to the number of electrons in that element. Okay? All right, let's look at a bigger one. Carbon is number 6 on the periodic table. Here's carbon. Okay, so carbon is number 6. This is a little bit of a bigger element. So let's see if we can do this for carbon. Once again, I'm always going to start with 1s. That's always the first place that I go. I can put 2 electrons there. The next place I get to, right, if I'm going down these red lines, that's the path, right? Go down the red arrow, go down the red arrow. Okay, the next place I get to is 2s. This is once again an s orbital, so I can put 2 electrons there, maximum. Okay. How many electrons do I have left? Okay, think to yourself, right? How many electrons do I have left? If I started with 6 and I put 2 here, and then I put 2 here, that means I have 2 left, right? Because I put 4 here, so I have 2 left over. So where do those final 2 electrons go? Well, that's where we have to consult the chart again. So I get to the end of this line here, 2s. I filled that up. Get to the end of the arrow. Go to the beginning of the next arrow. Come on down. 2p is the next place I go to. Okay, it's not 3s. I'm not just going straight down this list. Okay, that is not what I'm doing. I'm following the red lines. Okay, the red diagonal arrows is what I'm using to determine the order. Okay, I'm not just going straight down this list. Okay, so it's 1s, 2s, 2p. That is the next place I get to. Okay, and like I said before, we have 2 electrons there. All right, these little numbers should add up to our number of electrons, or our atomic number. All right, and then the last one here is aluminum. 13 electrons in aluminum. So, or 13 is the atomic number for aluminum, so 13 electrons. All right, let's see how we do on this one. So it's going to be 1s2, right? You'll notice that this gets very repetitive, okay? Then 2s2. All right. What comes after 2s? Well, we just determined that it was going to be 2p, right? After 2s is 2p. All right, so that is the next place I go, 2p. How many electrons can I fit there? Is it 2? No, right? If you look here, p orbitals are bigger, right? That's sort of the difference between s and p orbitals. P orbitals can hold 6. Do I have enough? I think I do, right? I started with 13. So let me put 6 there. Let me count. Okay, so how many have I used so far? 2 plus 2, that's 4, plus 6 is 10. So I still have 3 left until I get to 13, right? So I need to put 3 more after this. Okay, so let's figure out where those would go, right? Because I filled this 2p orbital up. I filled it up. So after 2p comes 3s. I can put 2 electrons there, right? Because s can only hold 2 maximum. Now I have 1 left over, right? Because these numbers add up to 12 now. So I have 1 left over. After 3s comes 3p, okay? So 3p1, right? Because I only had 1 electron left over. All right, so a couple of notes. The red lines, those tell you the order in which you go. These numbers down here, you're not always going to have that number here. This number just tells you the maximum number of electrons that can fit in any of these orbitals here, okay? So sometimes it's going to be that number, right? S2, S2, P6, S2. But at the very end, it might or might not be that number, right? So this was only P1, and that's because I only had 1 electron left over. right? So it's not always going to say P6. At the very end here, it's going to be whatever you had left over, okay? So that's it. Okay, that is how you write electron configurations. And this is the address of where all of my electrons are in aluminum, for example, right? Okay, we'll do a little bit more practice with this together after the video, but your assignment is going to be asking you to do the exact same thing, okay? And you're going to have this diagonal chart available to you, and this is what you're going to need to use as you're doing all these different electron configurations for these elements, okay? All right, thanks a lot for watching, guys, and I will see you guys right after the video.